paying attention or something like that. So, intercepts. What's another word for intercept? Crossing. Okay? So the first part of this is very, very simple. We're going to look to see where does the function cross the x-axis and where does it cross the y-axis. So let's look at this function right here. Okay? My x-intercepts, I'm going to do those in yellow. My x-intercept is the x-coordinate of the point where a graph crosses the x-axis. The x-intercept is the x-coordinate of the point crossing the x-axis. And of course, the y-intercept is the y-coordinate of a point where the graph crosses the y-axis. So let's look at this little crazy guy over here, this little whoop-de-whoop-de-whoop function on this graph, right? How many times does this function cross the x-axis? Show me on your fingers. How many times do you see it cross? Good. Alex, Matthew, Oscar, Arlie, Emily. Ooh. Some of you got one too many. Good. 3 times. Once, twice, thrice. Okay. So I have x-intercepts at what's the coordinates for this first x-intercept over here? If every box is 1. -4, 0. What about this one? -2, 0. What about that last one?
1.25. Yeah, you know what?
Yeah, it's a little less than 0.5. I'll call it 1/3, comma 0. Or 0.33 repeating, comma 0. I'll zoom in. I see some of you in the back struggling. Is that better? Okay. So, anytime my function crosses the x-axis, we create an x-intercept. Pretty straightforward, right? How many times does this function cross the y-axis? Once. Right here. Who could help me out with the coordinates of my y-intercept there? What would my coordinates be for that pink point? Right here. 0, 3. Very close. 0, -3. Everybody cool on that so far? Yeah, give me a thumbs up. That sounds good to you so far. Okay. Skip this part. Let's go down to this graph right here. Show me on your fingers. How many x-intercepts does this function have? 1. Here's my x-axis. Here's my function crossing it. What are the coordinates of that x-intercept? 3, 0. Is this function linear or nonlinear?
Linear.
What does linear mean? Straight line. So is this one linear or nonlinear? Linear. What about the first one we did? Nonlinear. How many y-intercepts do we have for this linear function here? How many y-intercepts? Arlie says 1. I agree. Son agrees as well. I have 1 y-intercept all the way up here at 0, 6. Okay? Okay? Real quick, find the x and y intercepts for this third function, this other linear function. This should be one of each. Typically when I have a linear function, I'm going to have one of each. Or none. Take a moment, identify the x and y intercepts for this linear function. Good. Good.
I'm actually doing good on this section.
Good job, Oscar. You're welcome. Ask them for That's a nice one. Ask them for
So, something to keep in mind, right, is when I have an x-intercept, my y-coordinate is 0. But when I have a y-coordinate, when I have a y-intercept, my x-coordinate is 0, right? So we got to keep that in mind. Who can tell me what's my x-coordinate here for this guy? -2, comma 0. That's right there. What about the y-intercept?
0, -7.
1, 2, 3, 4, 5, 6. 0, -6. All right. Now, how many x-intercepts do I have on this guy? This parabola, this downward-facing parabola. How many x-intercepts do I have here?
2.
Show me on your fingers real quick. How many do I have? How many do you see?
Wait, X.
2 of them. At, what are my coordinates for the 2 of them? Bless you. 1, 0, and 4, 0. Maybe these squares are too small. You guys are miscounting like crazy. How many y-intercepts do I have? Just one. Where is it at? 0 for sure, comma. -4. Don't worry.
Yeah, it looks like
This is as small as they'll be. They'll get bigger. Don't worry. Try that last one. Find the x-intercepts. If there's multiple, there probably is because it's a parabola. And my y-intercept. Should have 3 points. 2 x and 1 y. Keep in mind the scale of my y-axis is a little bit different. So you're going to see kind of a different looking number on that y-intercept.
The y-axis was 0, 12.
Did you get -4, comma 0, and 3, comma 0, and then 0, comma -13. Yeah.
It's 12.
Oh, I mean 12.
Oh my gosh.
Perfect. X-intercepts. Who's got the far left one? What's my coordinates there for that x-intercept? Isaac? -4, comma 0. And what about this other guy all the way over here? Who's got that one, Levi? 3, 0. What about my what? Thank you, fellas. What about my y-intercept all the way down here? Yeah, Oscar?
I got 0, comma -12.
Perfect. Give me a thumbs up if you got those 3 points as well. Good. We all feel pretty solid with the intercepts now, right?
Yeah.
Okay. That's the easy part. This is the part that gets people all tripped up. And I don't know why. Let's go. We're going to start easy with these linear functions. We're going to start with this guy right here.
That's negative.
Okay? What we're going to find now, I want to make sure everyone's paying attention because if that was like you didn't even need to use your brain to do it, you might need it for this. We're going to discover or identify what intervals this function is positive and what interval this function is negative. Interval means I'm going to have one of my little inequality signs. Okay? Kind of like domain and range. So I know that a function is positive when it's above the x-axis. So what I'm going to do is I'm going to find my x-intercept, and I'm going to draw a vertical line through it. Okay, everybody do that real quick. An x-intercept, by nature, means I'm switching from one interval to the next. If I'm crossing the y-axis from above, now I'm below it. If I'm crossing it from below, now I'm above it. So I'm going to make a line here because that shows me exactly where my interval is going to change. Okay, let's look at the left side of this function. When I'm talking about this function, I mean this straight line, this diagonal line. Is this portion of my line above the x-axis or below it?
Above.
It's above. I'm going to highlight this section in yellow. Everyone see what I did there? I covered up the right side. I asked, is this function above or below the x-axis? And I see it's above, so I highlight that in yellow. Now I'm going to cover that side up. See this little tiny portion of my function down here? Is that above or below the x-axis? Below. So I'm going to highlight this little section in pink. How many little squares of our graph did we not color in?
Like 2.
2 of them. I should say rectangles, right? These little rectangles are not going to receive a color. Why do you think that is?
Because they're not part of the line.
They don't have part of the line in them. They're just dead space, right? So the way that I always like to think about this, the analogy that kind of worked when I was learning this, is we want to think of the x-axis like the ocean, okay? Anything above the ocean, right? This is where all the birds are. This is where all the people are. Anything down here below the ocean in this pink zone, that's where all my fish are, and my sharks and dolphins and octopuses and squids and all that kind of stuff, right? You guys know what's in the ocean. So if I'm a bird up here, right, I'm on this part of the line, I'm a bird above the ocean. You guys ever seen birds dive for fish before?
No.
Yeah, some of you have. I'll look up a video later. But if I've got a little bird up here, right, he's in the positive section. He dives down, 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 hits the ocean, goes under the water and gets his little fish, and then he'll come back up. So I don't know if that analogy works. That may be confusing you more. But here's my positive section. There's my negative section. The way that we're going to write this is my function is positive when x is less than positive 3. When x is less than positive 3. Where did I get that positive 3 from? Matthew? From the x line? From the x-axis?
Yeah.
Kinda. What's on that x-axis at 3?
Negative.
At positive 3. What did we have there that we just spent 10 minutes talking about? Precious? Our dot. There's an intercept right here. Remember, like I said, the intercept, the x-intercept, is where my function changes. Because if I'm above it and I intercept it, well, naturally the next output's going to be below it. Okay? So my function is positive anywhere x is less than negative 3. Someone give me a number less than 3. 2. Okay? Here's 2. Is that in my positive section of the function or my negative section?
Positive.
It's in my positive. Something way less than 3. What about negative 4? Is that in my positive section or my negative section? It's in my positive. And this is where it gets confusing because I'm on the negative part of my x-axis. But I'm not talking about that. I'm in the positive section of my function. Okay? What do you think I can write for my negative section? Any ideas?
Y.
Yeah, Connie?
X is greater than 3.
Perfect. X is greater than 3.
That's it.
Yeah. I think I know what you're going to ask, but I'm not going to answer. I'm just kidding. I don't know what you're going to ask. If you think of it, let me know. Or if you want to ask it, let me know.
Me?
Nope, Levi.
Oh.
So essentially what this positive negative is saying is when I put in an input, what is my output? That's all it's saying. So when I have an input greater than 3, like say 6, bless you.
Bless you.
If I plug 6 into this function, my output is going to be negative because it's going to be all the way down here. You see that? Does everyone see what I mean by that?
Yeah.
This line right here, right? We could actually write the equation for this line. This is y is equal to negative 6 over 3, negative 2x plus 6. That's my function, right? That's our next unit. Just going over that stuff again. But this is my function, negative 2x plus 6. So if I plug in an x value greater than 3, let's just say 5. Everyone with me? 5 is greater than 3. If I plug in 5 here, what's my output going to be? Negative 2 times 5 gives me what? Negative 10. What's negative 10 plus 6? Negative 4. That gives me an output that is negative. Okay? What if I plugged in an input less than 3, like 0? If I plug in 0, what's negative 2 times 0? 0. What's 0 plus 6? 6. My output is positive. That's why that interval is my positive section. Okay?
Yes, I get it.
Quick show of thumbs, how much sense is that making? Because I told you it'd be a little bit more confusing.
100%.
Not making any sense? That's crazy.
I don't understand.
Okay, let's take a look at the next one. Maybe it'll make more sense. Do you guys see an x-intercept there? Yes. Where is it at? X-intercept is at where? Negative 2. I'm going to draw a vertical line straight down that negative 2. Because that's my only x-intercept, I know that my positive interval is going to contain negative 2, and my negative interval is going to contain negative 2. Right? Now I just have to figure out what direction my inequalities are going to go. Okay? It's either going to be opening up or kind of closing up, right? So, let's look at the left section of my function first. If I covered this guy up, and I look at my left side of the function, that tiny little arrow there. Is that up in the sky or down below the ocean?
Up in the sky.
Up in the sky. Is that positive or negative?
Positive.
Positive. I'm going to highlight that part in yellow. Okay, then cover up the left side of your line. Those are the notes we're working on right now. Now I'm going to cover up the left side. This portion of my line, is that up in the sky or down in the ocean? Down in the ocean. Is that positive or negative? Negative. I'm going to highlight that in pink. So my positive interval is going to be the interval where x is less than negative 2 or greater than negative 2. There's my x-intercept. Is my yellow highlighted section less than this number or more than this number? Less. Negative 3, negative 4, negative 5. Those are all my yellow section. You see that? Nod your head yes if you see what I'm talking about. Okay. So I'm positive when x is less than negative 2. Here's negative 2. All my x values greater than negative 2 are in this pink negative section. So my function is negative when x is greater than negative 2. It clicked. I see that. That's good. Are we feeling okay with those two now?
Yes.
Yeah, a little bit better? Okay. Let's kick it up a notch. Here we have two x-intercepts, which means we're going to make things more complicated. We've got more intervals that we're going to be talking about. So, at my x-intercepts, what am I going to draw?
Line.
Vertical lines through both x-intercepts. Now I have 3 sections. Let's start with the leftmost section. Is this section up in the sky above the x-axis or down in the ocean below the x-axis? Down in the ocean below. What color am I going to highlight that part of my function? Pink. That's a negative interval right away. So I know that anything less than 1, that's going to be negative. I'm going to keep that in mind, okay? Let's look at the middle section. That little bump in my function bump. Is that up in the sky or down in the ocean? Up in the sky. What am I going to color that part? Yellow. Now this is a closed interval. It starts and stops at a specific point.
So
Let's keep that in mind too.
So the bird goes under the ocean, goes back up, and goes back under.
Sure. What's this section right here? Above or below? Below. I'm going to highlight it pink. Right? Bless you.
Thank you.
So this function is kind of like a dolphin. What do dolphins love to do? Jump. So here's a dolphin. He's under the water. He hits that surface and breaches. He jumps, and then he comes back down, goes back down under the water. You guys kind of visualizing what I'm talking about with that? Yeah? Anyone ever seen a dolphin jumping out of the ocean?
No, not yet.
Live? Yeah?
Yes.
So the dolphins down here in the negative space, they hit x equals 1. They jump up. Now they're positive. They're in the air. They hit 4, and they go back down. So that's just what I'm going to mirror with my intervals. The only section that I'm positive is this little yellow section right here. Where does that section start on the x-axis? 1.
1.
Where does it end?
4.
4. So I know my function's positive when x is greater than 1, but less than 4. This is like with our domain. If I have a closed domain, right, I end in 2 dots, no arrows going on forever. I write myself a little compound inequality is what it's called. I got 2 of them, and I put them together. And what this says is that as long as my x is in between 1 and 4, my function's positive. That's what this little section right here says.
So y
Does that make sense? Now I have 2 separate intervals for my negative. So when x is what? Anyone want to help me write this interval? And we got to write 2 separate ones. Isaac, x is what? We'll get to that one. What's x less than first? 1. And x is more than what? 4. When x is less than 1, that's this whole side of my graph. Here's 1, 0, negative 1, and negative 2 are all less than 1, aren't they? So in that portion of my graph, my function's negative. Anything greater than 4, 5, 6, 7, 8, going all the way to the right, that's also negative. So when x is less than 1 and x is greater than 4, those are my 2 little negative sections. But I have a closed positive section. Starts at 1, ends at 4, everything in between, nothing on either side. Does that make sense? A little bit? No? Okay. Let's see how much sense that makes. Give the last one a try on your own.
Okay. So first,
Something I want to point out. With this, the y-intercepts mean nothing.
okay.
We'll talk about what they mean on another day, but today the y-intercepts mean nothing. You're focusing on your x-intercepts. Okay? In this one, my x-intercepts were 1 and 4. All of my intervals had 1 and 4 in them. Okay? Keep that in mind with that last one. Take like 60 seconds or 2 minutes. See if you can do it on your own or with the person next to you. I'll come by and see what you guys come up with. Do your highlighting though. It really helps visualize what our intervals are and where they are.
this side pretty very.
Nice highlight.
Yeah, no, I like it. This side right here is basically positive. Oh, I got it because it's a dot.
So
Like
it's
no, like this, like this.
Negative. It's negative 5. It's negative.
so positive is above the x-axis. See how it's yellow? So you do have
But I get the highlighter part. I don't get my off the I think I
So, see how you wrote this compact inequality? Between -4 and 3, what color is my section? Pink. Is that positive or negative?
I'm just gonna highlight it.
That's negative. So these are bad. The colors are not bad. These two are bad.
Oh my gosh,
Yeah.
not there.
So, you highlighted
I got
opposites.
I got this. I got
See how
-4
all my
is
blank sections are where
negative
my
4
eyes are at.
less than x, but greater than.
Right? So I think you just kind of mirrored this one, but we only have the yellow
Where?
up here because that's where the function is, right? My yellow sections here are on this right corner and this left. Does that kind of make sense? See if you can say it. Work together. Any comments? Is my contained interval above the x-axis or below? Below. That's going to be negative, not positive. Keep going, don't worry. I still want to see what you guys are doing. Very nice. Less than -4, greater than 3, between -4 and 3. Beautiful. Good job.
I get it.
Positive x is greater than -4 and greater than 3? That doesn't make sense. See if you can fix that. Highlighting looks good. Highlighting looks good. Positive interval is my contained interval, my little loop, my bump. Is it above or below the x-axis? Take a look. Where is it?
Mr. Church.
Well, then on the fourth one, it's below. So is that a positive interval or a negative interval? Negative. You got them backwards on. My arrows should always be going the same way. So you're very close. So my contained interval is when I'm going to make the compound inequality, right? See how here my little bump, my contained interval was in the sky? Where's my bump down here? In the ocean. Is that a positive interval or a negative interval? That's negative. So when I make a compound inequality, my arrows need to be going the same direction. So I think you've got this. The second one needs to be flipped around.
Okay, better or not
Okay.
better?
But again, the compound inequality is below. See how my bump is yellow, but here my bump is pink? So instead of a positive compound inequality, I have a negative compound inequality. These two need to go a little bit around. Yes, except this one, my section is positive when x is less than -4, not greater than.
Does the positive have two answers? Or just one?
So yes, see how there's two separate yellow sections that aren't touching? That means I'm going to have two completely separate intervals, just like I had here with the pink. But I got one big pink section that has a start and a stop, right? Does it extend all the way to my corners? Like this pink section or this pink section? It's contained within -3 and 4, whatever. 3 and 4. -4 and 3, yeah. So, when I have a one of my intervals should be a compound interval, one of them should be two completely separate, right? The bump is so that's where's my bump on this one?
I just don't
I don't have a say. I just yeah, I just asked a All right, let's take a look. I saw a lot of great problems. I love problems. That's why I'm a math teacher. What I'm going to do here is I'm going to make a vertical line through my x-intercepts at -4 and at +3. Now with a parabola, it's an interesting situation. I have one section that's contained, and I have two sections that go on forever, right? If I look at this, my left side, is that contained or does it go on forever? Do you see an arrow? Yeah, and it goes on forever. You're right. Is it above or below the x-axis?
Above.
It's above. What about this far right-hand side? I see an arrow. I know that goes on forever. Is it above or below?
Above.
It's above. So where is my contained section, above or below?
Below.
Below. That's this big bump down here. Now this is different from the previous one because my bump was yellow in the other parabola because it was upside down. But now that it's right side up, my bump is down below. So this contained section, that's when I'm writing I'm going to add this in here, compound inequality. Go ahead and write that in. Now my compound inequality, I might not have one. In the straight lines we saw, I didn't have one. Right? But when I have a parabola, odds are I'm going to have to write a compound inequality because my bump is either going to jump over the surface or dive down below the surface. Ken, you got a question? No? Okay. So, my bump, is that above or below in this one? Below. That's going to be a negative compound inequality. From -4 all the way to +3. From -4 all the way to +3. I'm talking about x values. Right? And my arrows are always going to be pointing to the left. X has to be greater than -4, but less than +3. Make sure your inequality for the negative looks just like mine. Right? Now, my positive, how many intervals do I have that are positive here?
2.
I got two separate ones. See how they don't touch each other? Right? That means I'm writing two separate inequalities that don't touch each other. These ones touch each other. They overlap. Because these yellow sections don't, I'm going to mirror that in my intervals. I'm going to have one interval and I'm going to have another interval. Okay? So this first yellow interval, I know that it's at -4, so x something -4. And my other yellow interval starts at 3, so x something +3. Now I just got to fill in my inequalities. My yellow section, is that less than -4 or greater than -4? Less than, thank you. Again, you could just test it out. Pick -7. That's in this whole yellow highlighted area. That's positive. So anything less than -4 is positive. What about 3? Should I have a greater than or less than symbol here?
This one.
This one's greater than? You read it left to right, yeah, greater than. The alligator eats the greater one.
Yeah.
So if my mouth is open to the left, that's a greater than symbol. My mouth is open to the right, that's a less than symbol. So x is greater than 3. Anything to the right of 3, if I picked +6, that's in my yellow highlighted section. All right? So that's positive. The arrows tell me it goes on forever. That's what's important. That's why we have two separate inequalities. with my bump, in this case it's down below in my negative section, I've got the compound inequality. All right?
That makes sense.
Quick show of thumbs. How much sense is this making now?
100%.
Good. We got one more to do. Let's go back to the top.
Yo,
This guy's a little bit uglier.
Yeah.
Okay? How many x-intercepts do I have here? I've got 3. I'm going to make one line down there, one line down there, and one line, it's kind of hard to tell, right there at 1/3. Actually, you know what? Let's stop.